Our next session on the agenda is the first panel discussion titled Securing Industry 4.0. I'm going to introduce each of our panelists by name and title, as well as our moderator, and then we will hand it off to the moderator to control the discussion. Again, I would remind all the attendees that there is a Slack channel that is tied to this panel. Please drop your questions in there. We will get to those questions at the end of this talk. During Kevin's talk, since it was pre-recorded, he was able to answer many of those questions inline live. We won't have that opportunity because we'll be keeping the panelists busy. So with that, I'd like to introduce our panel. Our first panelist is Dr. Wayne Austad, who is the Chief Technology Officer and National Homeland Security S&T at Idaho National Labs, the Department of Energy Laboratory. David Chan, the Global Manufacturing and OT, Operational Technologies Cybersecurity Program Lead at Eli Lilly. Professor Nate Hartman, the Dauch Family Professor of Advanced Manufacturing and Department Head for Purdue's Computer and Graphics Technology Department. And then Professor Aniket, Associate Professor of Computer Science here at Purdue. And our moderator is CERIAS Director and the Samuel D. Conte Professor of Computer Science at Purdue University, Dr. Dongyan. Gentlemen.
Thank you, Joe. So this is live from West Lafayette, Indiana, the United States of America. Everyone, welcome to the first panel of the 2020 CERIAS Symposium. So this panel will be on Securing Industry 4.0. I'd like to thank Kevin's keynote again, because his keynote set a perfect context for the discussion here. Let me first show you just a couple of slides. First, we would like to kind of semi-formally define Industry 4.0. This is what I just captured from Wikipedia. So basically, Industry 4.0 is the ongoing automation of traditional manufacturing and industrial practices using modern smart technology. Large-scale machine-to-machine communication and IoT are integrated for increased automation, improved communication and self-monitoring, and production of smart machines that can analyze and diagnose issues without the need for human intervention. So we would like to actually look at the security of Industry 4.0 from an end-to-end perspective, ranging from the integrity, authenticity of raw materials all the way to the privacy and security of end users and customers. So as you have seen, the entire manufacturing and Industry 4.0 ecosystem is a large-scale end-to-end system, spanning from multiple layers, multiple tiers of suppliers to OEMs, to distributors, and to consumers. So any point, right, any portion of this global network poses challenges both traditionally and in an emerging sense, security and privacy threats. So if we are looking at the deployment, the increasing deployment of IT plus OT technology across the ecosystem, you can actually see that the multiple components of the ecosystem is being digitized or cyberized with deployment of sensors, controllers, robots, and various communication, wired and wireless communication technologies. And now on top of that, we have artificial intelligence and data analytics controlling the critical parts of these operations. So within this ecosystem, we have seen the emerging threats that increasingly compromise or pose a threat in different parts of the system, ranging from manufacturing floor to the supply chain network to the end user customer privacy. In communication, between the cloud, the manufacturing physical site, the controllers, et cetera, et cetera. So this is obviously a complicated, large-scale system, and the study of cyber and cyber physical security to secure the entire end-to-end, so I emphasize the end-to-end aspect of Industry 4.0 poses significant challenge, and they also create very interesting research and development problems to address. So today, we have the pleasure of having 4 leaders in Industry 4.0 security joining us, presenting their vision and their observations, insights into this problem, and also to have a discussion with the audience on related issues. So as Joe introduced, we have a stellar panelists coming from national labs, Wayne Austad, and industry, David Chen, and also academia from Purdue University, Nate and Aniket. So without further ado, let's actually start the panel discussion. So the format of the panel consists of 3 parts. In the first part, each of the 4 panelists will each give a 5 to 6 minute position statement. And after that, we will have a Q&A session where I, as well as audience, can ask questions, to the panelists. And in the remaining, and finally, in the remaining 10 minutes, we do offer opportunities to our attendees to speak up and to share his or her opinions, comments, and suggestions. So attendees, at this time, I would like to invite you again to join our the Slack channel that is created just for this panel. If you go through the list of the Slack channels, you should be able to find the Tuesday_02_ panel. So that's the Slack channel that we will be using for Q&A or for posting your questions, and I will be monitoring that channel and pick up your question, and I will convey them to the panelists, for the after their position statements. So now, without further ado, I would like to hand over to our first panelist, Mr. Wayne Austad from Idaho National Lab, for his opening and the position statement. Wayne?
Thank you, Dongyan. I'm just going to bring up the slide here if I could, so you can see this, I hope. Okay, yes. So when we think about going to Industry 4.0 and beyond, really the key is trying to get to some form of proactive and pervasive security. And there are at least 3 things that come to our minds here at Idaho National Laboratory and other places. One is we really have kind of an evolution or a battle of architectures going on. And when you look at the historical models for security, the Purdue model and ISA 95 and 99, they're really centered around the engineering model of the process. And there's still some inherent trust that is in the lower layers of the control loop associated with the data and the command layers. And when you look at the new reference architectures for industrial Internet of Things that add a lot of goodness in encryption and security protocols, they're very data centric. And so there's some positive things that will happen with the protocols and communications and supporting of different abstractions and data science that you can add to security. But I think it's going to be important that we really continue to understand the fundamentals of the control loop and think about security in the context of those end devices and end sensors and actuators, depending on whether you're using your IoT and the automation side or the supply chain side. And so we're going to have to manage these risks and benefits of coexistence of what I'll refer to as suboptimal architectures until such a time as we have a more fundamental and a more unified architecture that looks at both the data sides as well as the process control sides. The second area is, and I think it was very well presented in the diagram that Dongyan showed, is that really automation security and supply chain security in modern industrial factory floors are interlinked. There's layers of interdependencies between the chipsets and the motors and the larger systems that you're controlling, and what we're desiring in terms of an optimization for a more agile or resilient supply chain that particularly COVID-19 has shown the importance of. This is also in the face of a full life cycle of digital engineering practices so that we move away from sort of a document-oriented engineering process in which each stage may take the data in different ways and produce a different document or data file. And really you're getting into more integrated data sets, integrated mod and sim, direct loading of configurations on your manufacturing plant floor, driven by these engineering tools that are permeating through the life cycle. So optimizing this for the different types of ROIs in the cyber, physical, often the energy efficiency world, while you're trying to achieve agility and resilience is going to be important to be able to do that in a unified fashion. And then finally, the long challenge that we've had in cybersecurity, besides appropriate risk measures as technology evolves, is really that measurement and validation of security through these different layers that we're adding and through the life cycle of the products. You know, the example I have in that picture from SMUCON is, you know, just a simple mismatch of an architecture or the dropping of a particular compiler flag. You may be patching a particular higher level vulnerability, but introducing much more vulnerabilities in the binary layers. And we see this in particular in the Internet of Things and small device. And so we're going to have to get to some level of adequate formalism based on real measurements and validation without getting caught up in the ever search for absolute formalism and formal methods. And so those are just my thoughts, Dongyan, and I'll turn it over to the next.
Thank you, Wayne. So let's move on to our industry panelists. David from Eli Lilly and Company. David, if you please.
Thank you very much. I don't have any slides, but I have some talking points prepared. You know, when we think about Industry 4.0 and digital plant, we see that it is moving extremely rapidly in industry. There's such value around, you know, autonomous robots, AI, you know, advanced analytics to do predictive maintenance, so that, you know, we can run our equipment more productive and we can reduce the cost of manufacturing, the cost of products sold in manufacturing. Track and trace, you know, we talked about end-to-end supply chain. You know, in the pharmaceutical industry, there have been government regulations around deep supply chain and a concept called serialization. And that's a challenge that the pharma industry has had to meet and continue to meet and exceed, you know, further and further requirements as they come along. So, you know, the position overall from an Industry 4.0 position is it's here and it's moving fast. And our different business units are really seeing that value and asking for these capabilities. Some of the more historical plays, you'd see a lot of OT or IT shops asking and embracing that technology. Now we're seeing business units across everywhere clamoring for these great business outcomes that are achievable. I'd say 4 other main points would be, you know, in order to tackle from an industry perspective, we need to look at Industry 4.0 as a holistic strategy. It is very easy to be enamored by the technology and what can come with the latest and coolest, you know, technical capabilities. But from deploying in a very large enterprise with manufacturing sites located worldwide, some companies have maybe only a handful, 15, 50, maybe even 100 manufacturing sites. It's around the integration of people, process, and technology to get that value. When we look at the solution space, you know, that solution space and some of these products that can help ease the integration of security tools and capabilities in Industry 4.0, a lot of them are newer and evolving very, very fast. In industry, you know, it's around being very deliberate around piloting and doing proof of concepts, realizing that business value and quantifying it, and then coming up with a game plan on how you're going to deploy it everywhere effectively. Does the technology scale well at an enterprise level? Another key would be around collaboration. So, you know, large companies have very large matrix organizations and they're very complex. We talk about the IT, OT, you know, synergies. Now is even more important, along with all the different third parties that we're using and collaborating with IT, OT, third parties, and all the business areas. You know, from a security perspective, we don't want to be the voice of no that blocks the use of this innovation because of security concerns. We need to be able to partner with the different business areas and the existing processes, be it from engineering, quality, operations, et cetera, so that we can help enable those business transformations and help build them in securely. So really, you know, collaboration is absolutely key. You know, we don't want to stifle innovation. All these different departments and all these different business units that have this, you know, huge excitement are championing, piloting, and creating programs. We want to be able to incorporate all those learnings from a corporate level and replicate them across. We don't want to say, no, let's wait for the big program. We want everybody to be able to continue to be innovative. I'd say the last key talking point that I wanted to highlight was, you know, it's all around risk reduction. And the gentleman from General Motors really hit the nail on the head there. You know, it's all around, like, you know, having your risk reduction, because yes, Industry 4.0 with all the devices and the explosion of, you know, IoT devices and industrial IoT devices, yes, it's increasing the potential attack surface area. And so, you know, you need to be able to prioritize with your limited resources around people and money where we can get the biggest risk reduction that is acceptable for the company and for your area. A lot of the traditional IT security concepts play very well in ICS and security and Industry 4.0. So, you know, again, when we think about it in industry, a lot of it is around maintaining this install base. So there's a lot of cool interconnected devices. What happens when I have thousands, if not millions, installed all over my enterprise? How do I have that detailed asset inventory to do good vulnerability risk management of all the different brands and types and updating all that firmware? How am I going to segment those devices so I have micro segmentation so that, you know, I can actually have the right risk posture where they're located? And then lastly, it would be around anomaly detection, monitoring our area so that we can do proper incident response.
Thank you, David.
Thank you.
So now let's move on to hear what the what folks in academia will have to say. So let me invite Nate to present his position statement. I know that, Nate, you have some slides to share.
Yeah, sure. Thank you, Dongyan. I'm going to go ahead and share my screen right quick. I just have 4 of them that are really meant to be thought provokers and things that will hopefully generate some conversation. The first one is about digital disruption. And so, Dongyan, when you asked me to present on or be part of this panel, one of the things that it made me begin to think about is the platform that Industry 4.0 essentially operates on. And I adapted this slide actually from one of my colleagues who works at Oak Ridge, but the initial part of it was we've seen this transformation that's illustrated on this slide, and people are becoming more and more fixated on data. People are becoming more and more fixated on the creation, the exchange, the consumption of that information and the value that data has in an environment like this. However, what can't be lost on us when we talk about security is the fact that not only is data often changing form in this case, especially across a manufacturing enterprise, but it's also changing in its platform, moving from this concept of physical information and localized information to digital information and cloud-based information. And this transformation continues to occur rapidly. And in many respects, you know, I was responding to a point on the chat just a minute ago about someone asking about Windows XP, right? You know, how long has it been since most of us have used Windows XP? But in an industrial setting, that is still very much alive and well, and something that we have to be able to overcome. So I would leave you with this slide from the perspective of the change in form to the change in a platform, from physical and local to digital and cloud-based. Secondly is a little bit of historical context, and this is where you'll see my manufacturing roots come out. that in many cases we collaborated around this concept of a technical drawing in the lower right corner. And, you know, we didn't have to worry about Mylar or paper version 2.0. That wasn't a problem for us. However, we also had situations where communication was often serial. Collaboration with someone often meant face-to-face, and you trusted, you know, and this is definitely a cybersecurity concept, you trusted that data because you often trusted the person that generated it. You knew them. Or maybe I suppose conversely, you didn't trust it because you knew them. But, you know, the point being is that we're moving obviously very rapidly away from this paradigm into a situation where our modalities for information and how we communicate them are changing. Our modalities for who or what maybe that we're communicating with is also changing. And so if we think about this as a way to move information across modalities, not only do we have to move shape definition, behavioral definition, contextual definition across a manufacturing enterprise, we may also have to do it between human and non-human actors. And that's incredibly important from a security perspective, especially when we get to this portion that's down here in the lower right corner, which is machine-to-machine communication. You know, humans can still mitigate certain amounts of things, but when we get into a machine-to-machine environment where we're relying on automation, where we're relying on machine learning and intelligence, we're not able to mitigate as much in many cases. And finally, I would say, if you look at the circular figure here, we've all seen figures very similar to this. And the idea is that we're using things like data and analytics, but also using things like standard interfaces and formats to sort of control or at least try to stabilize how we share information across an enterprise, especially one that is as broad as a digital enterprise or as broad as an organization that is practicing Industry 4.0 fundamentals. And so when we think about where security or the notion of security potentially arises, is that we have you know, digital product definition in layers, we have digital process definition, we have digital systems definition and the like, but these end up in multiple different information modalities. And it's going to require a solution not only for human security, but machine security. And we have to be able to secure the infrastructure and the data, especially at their interfaces. And so with that, Dongyan, I will pass back to you.
Thank you, Nate. Next, I would like to invite Professor Aniket to talk about his observations and insights. Aniket?
So I also have slides to show. Just to give my background,
sure.
I generally like working on cryptography and distributed systems. And indeed, my interest in the space of Industry 4.0 typically are associated with how can we use the distributed systems and knowledge from cryptography in this space. And in particular, I'm interested in blockchains. And let me share my slide. Okay. All right. Yes, so indeed, what I'm curious about and want to understand more is how to employ the blockchains in terms of the improving the supply chains, especially the transparency in the supply chain, as well as improving the counterfeit detection and traceability in general. As I started to work on that maybe 4 to 5 years earlier in a couple of different contexts, from the automotive sector as well as in the food supply chain kind of environment, I realized that it's much nuanced. It's not that we can just take some solutions and just apply them, take those solutions and just apply those to the scenario that we got, and voila, we have achieved what we want to achieve from this environment. As we started looking into here in bit more detail, we started to come up with nuances, and many of those nuances come across an interesting trade-off with respect to the transparency of the information and the privacy requirement that we come across when we look into such environment. And what I thought could be a nice thing to do here is I can show some very simple examples that can happen in different supply chain scenarios, and what can we do about them, and what can be challenge what can remain still as an inherent trade-off. So I'm going to take a very simple example for a supply chain. I'm assuming here I'm just showing a standard, maybe a manufacturing, could be associated with the automotive industry or stuff like that, where there could be different components from all different layers of tiers, like tier 1, tier 2, tier 3 suppliers. They come together, get formed, and get linked to each other to create a product. And that product is now taken from a manufacturer and possibly sent that to the some of the depot or some of the retail places that controlled by the manufacturer, and eventually will go to the dealers, from which it will go to the end users as that can happen. And when we talk about actually applying some blockchains to such a supply chain environment, we are talking about taking all these different components as this supply, as these individual components go through such a supply chain, that we can keep track of such information in some form or other, so that when things go wrong, we could easily backtrace or forward trace and figure out which people should be informed, how should we take action if you want to do some kind of analysis, that if you want to make this a change into a supply chain, how that will affect different part of the supply chain. So starting from taking care of the user needs, to performing analytics, to tracing counterfeits, as well as tracing issues such as when, let's say, there is a particular outbreak in the food supply chain, and we want to figure out which customers or which final retail store that we should talk about, or which farm, on other hand, that we should take care of as fast as possible, is certainly something that we can do with the blockchain. So when I look at blockchain, obviously we have all this information available today. What blockchains or such infrastructure can offer us is an opportunity to do our analysis, our processing faster, so that we can indeed save that valuable time. While doing that, there's always challenges. And let me give 3 examples to talk about what kind of interesting thing that we look at. So let's take this simple supply chain, and there are 2 suppliers at my tier 2 level. And these are competitors. They may be providing possibly the same component to the tier 1 supplier. And now they can, is it possible for them to look at this blockchain environment or the logs in such an environment that are visible to them, and break the data or the metadata privacy for their competitors? It's a challenge, right? Now they can see that, oh, this competitor typically generates these, how in this particular frequency their components in this market, and typically they send to the tier 1 supplier in a particular rate. And just by looking at metadata, they can figure out this information. Very challenging. Another example could be that the suppliers may have interesting relationship with each other, and they may not want the owners of the blockchains to know that. So owners of the blockchain here could be the OEM who is maintaining such an environment. And now they could have challenged that their relationship that they want to protect can be exposed. And there is indeed a question that comes up in this context when people talk about blockchains for supply chain. And that question is precisely who owns the data, and what can we do here in terms of the privacy, so that we can make sure that we have transparency, but at the same time, now it should not be the case that OEM can just know much more about data, and basically some trade secrets or some trade practices that suppliers and dealers have are not getting compromised in such an environment. And the final one that I want to add is that it's not certainly sufficient that we have this at the individual vendor level or individual manufacturer level. It is for a better traceability, better counterfeit protection, we may have to go across different layers, across different sectors, and certainly across different manufacturers. Now, once we do that, again, combining this information while providing the best possible transparency and maintaining privacy is a challenge. And every system is different. What interests me more is to find out interesting patterns, and how can we solve those patterns using interesting cryptographic technology, so that we can get the best possible transparency while protecting the privacy, again, in the best possible manner. There will be a situation where they will come to conflict with each other, and my aim will be to demonstrate such a conflict and understand such conflict, and see then it will be left to more like an environment to decide how such trade-offs should be resolved. So yeah, these are the things that I find interesting, and happy to talk more.
Thank you, Aniket. Thank you all panelists for your very insightful position statements and presentations. With that, let's move on to the third part of the panel, the Q&A. So what I'm gonna do is the following. I do have a list of questions of my own, and I'm also monitoring the questions that are being posted on the Slack channel. So attendees, if you would like to ask a question, please do type your question on the Slack channel so that I can convey them to the panelists. So every time we ask a question, I would like to invite our 4 panelists to each answer the same question, in turn, so that we can actually learn your respective insights, suggestions, opinions. So maybe I, as the panel moderator, I should get the pleasure of asking the first question. And I would like to kind of discuss the elephant in the room, right? The pandemic, or more generally, black swan events like this, right? So how can we prepare for the unexpected? So my question is, what is your thought on balancing or preparing our Industry 4.0 and more generally manufacturing systems for unexpected events like this? And how can we balance the manufacturing system agility, security, and cost effectiveness in the face of black swan events such as COVID-19? Who would like?
I'll go ahead and start
Please.
out with that.
Thanks,
yes.
David, please.
So, definitely there's been a big change from a black swan event like COVID-19. One of the key differences is the amount of remote work, work from home. There's a lot of work that must be done on the shop floor. And so those critical jobs still have to be done on plant. But then you've got hybrid situations from the rest of the workforce where some are working remotely part-time, some full-time, et cetera. And so, one of those events is it has a lot more on your IT infrastructure in terms of being able to handle that remote traffic, just the amount going through your VPNs. And if you're using cloud infrastructure, distributing some of that load with your secure architectures. From a farmer perspective, this event really tests the agility of a company to be able to quickly pivot, quickly move, and react, such as, we're seeing around the move around trying to find treatments and vaccines. Historically, the time frames are much longer than we're seeing today. And that's that agility, and that's some of the abilities that technologies like Industry 4.0 are enabling, right? If we can collaborate effectively and remotely in labs and increase our productivity, we can get things moving faster and get to results quicker. So, what I'm seeing is a lot of these trends were already existing in the industry around being faster, being more agile, using more technology for collaboration worldwide. But what COVID has done is it's accelerated that. It's accelerated the need for that and the adoption for it.
Thanks, David.
Mm-hmm.
Dongyan, I'll piggyback a little bit on what
Sure.
David said, and also say that with respect to the technologies that often comprise a Industry 4.0 scenario or environment, a lot of manufacturing firms today still find themselves in some kind of a pilot deployment state or some sort of a test, right? And especially in a large corporation, there always seems to be a pilot test of something or other going on for some kind of a project. And IT and OT infrastructure deployments are really no different in that regard. And so I think one of the things that, and then just given the overall time span of where at least US manufacturing is today with Industry 4.0, I think many of them are still in a phased rollout and deployment of a number of these technologies. And so some of the things that would have enabled
maybe more rapid communications, or maybe more rapid scaling, up or down of their various architectures may not have been fully implemented within the company when all of this hit. And so, I think there's that consideration as well, that just from an overall completion perspective, I think, again, at least US manufacturing finds itself in this sort of precarious, semi-deployed, if you will, infrastructure of Industry 4.0.
Thanks, Nate.
Yeah, just to continue on that theme, Dongyan, if you look at some of the rapid responses where you had, automotive manufacturing plants re-rigging for medical devices, you had exchange of design files, you had trying to use advanced manufacturing techniques to print masks or print new components that were key to, say, ventilators or other things. It really put the pressure on accelerating those. But the key is going to be, if we're going to do that for the long term and at scale, we really need to address this binding of the secure automation and the supply chain side of things with the digital engineering tools we're using. And it can be a very powerful approach towards security if we choose to use it that way, as opposed to an incremental add-on or something that we use in a pressure situation. But I don't think we've spent enough time thinking about how we might integrate that as well. The other example I think was brought up in terms of the speed of vaccine development, from the power of the mod and sim based off of the genetic sequencing that we did, and how fast we can start analyzing what might be more successful protein combinations. Think about that in a larger manufacturing side of things, and how much you trust those individual exchanges, and how do we add to the mod and sim and the optimization the ability to validate some of the things that we're doing in a security sense, as well as the physical world sense.
Thanks, Wayne.
Yeah. So, yeah, this is all very nice discussion for sure. So I'd like to add just one point, is that now indeed, most of the industry that I saw was not prepared to deal with that, and they have to change, make ad hoc changes to their supply chain environments to deal with it. And maybe having a plan indeed in place for such environment, for such situations in the future could be an important thing, so that there is always a backup plan ready where things can really move faster. I mean, the example that I saw is that the meat being not available to now being meat being available in excess kind of things are very challenging and interesting example. It will be really good to have some kind of backup plan which crosses the boundaries of different industries together.
Thank you.
And if I may add
Please.
one more comment around that, he talked about meat being not available. That comes into the complex supply chain of being able to produce your products. So there's a lot of components and stuff that are within your manufacturing plant's control. But what if you can't get the right raw materials or the subcomponents or packaging materials,
right,
in order to provide enough, paper towel or toilet paper, et cetera? That complex supply chain, on the agility of it, is key for something like this, where demand can suddenly shift. And now your relationships with your third party and component suppliers and those needs are suddenly shifting too.
Excellent.
And I think to that point, Dongyan, and to build on what David said, I've experienced this on a few different levels, but when you think about, can you get components and can you get raw materials, sometimes some companies' insight into their supply chain is no more sophisticated than, clicking the tracking number link on, their favorite courier's website and figuring out where the truck is. And I think it's, that it's only going to get more problematic as supply networks continue to grow. And, the ability to sort of make and produce, the barriers of entry to that are becoming increasingly lower. And so, that insight, but also the security of making sure that the data that you're in fact getting is good, is important. And right now, there isn't, at least from my experience, enough widespread capability and capacity for analytics and intelligent decision making within the larger supply network.
Great, that's very insightful point. So let's move on to questions from the audience. Greg asked the following question. Zero trust, ZT, is the hot cybersecurity architecture concept these days. How practical and valuable do you see that for Industry 4.0 security? Or are security challenges different and not fully addressed by zero trust principles?
So I guess I'll start with that long pause. So while it's a good exercise, I think to go through things like zero trust in your mind, I think in the cyber physical domain, you have many control actions that don't necessarily fit that model of do you trust that particular data source, if you will. You know, in some of these layers and some of these implementations, depending on what you're controlling, you've already set up an inherent trust of exchange, right? And so how do we increase the level of trust, if you will, based on what physical or energy action that we're doing, and not just the bits and bytes of the transaction? So it's not an unuseful model, certainly since we have IT and OT systems blended increasingly. But from a practical standpoint, there are different parts of the hierarchy and different types of processes that we're controlling that I'm not sure that it's a good fit unless we think about how we extend it in different ways.
Yeah, I would say that it's definitely aspirational in terms of, you know, having those different layers of trust. One of the barriers to quickly move into something like that is, you know, you have a legacy in terms of a bunch of installed base,
right?
And you had high trust to begin with, and then to completely, you know, switch that to zero trust, that's a huge change from people, process, technology. So it's something that's definitely aspirational in terms of you try to do the absolute best you can, and you try to do it within certain segments. But can you really get to 100%? That really depends.
Okay. Thanks, Dave.
Dongyan, I would say also that I think if we're thinking about manufacturing in particular, in the context of Industry 4.0, I kind of alluded to this a little bit ago, where the barrier of entry, whether it be technology or capital funds or the like, for people to design and make products that they eventually want to sell, is becoming increasingly lower. And I think as I understand zero trust and the concept behind it, I think as that barrier of entry for people to design and make things gets lower, one might argue that the number of people doing that, or the number of organizations doing that, might go up. And so can we effectively control in a zero trust manner something that is that amorphous or that organic? I realize that might actually spark more questions than it answers, but you know, I think at some level, it might be a situation where we need a more adaptable, scalable security model than what zero trust implies at some level.
Great.
Yeah, I'll just add on to the nice discussion that came along, that when we teach security, we indeed talk about security by default or privacy by default, which are very much in the part of zero trust. But as already mentioned, going from where we are right now, we cannot just jump directly to the scenario where we can go for the zero trust environment. And probably creating a pathway could be an interesting challenge by itself. Are there nice intermediate steps towards going it? But as we saw in all system environment, even the environment that we're using with Zoom, right? And they probably do not give importance to zero trust in that sense. There is Zoom bombing attacks, and they happen after 3 to 4 years when there's indeed system started to get used quite a lot, which shows that actually it could be adapted, but maybe it's always better if when we are building products that we can be proactive about that, because not always there'll be opportunity to overcome those issues later down the line.
Great, thank you. So let's move on to the next question. Brian from in the audience asked, many times the OT devices require older technology to configure and update. For instance, in our environment, there are many that are device drivers and other software that require the use of Windows XP laptop to configure them. Unfortunately, since this operating system is out of support, we have had viral outbreaks when these laptops were powered up and used to maintain the OT devices, right? Do you see any improvement on the OT manufacturer side of things to keep their tools and drivers up to date to avoid OT causing IT security issues?
So yeah, I'll start with this one. I do a lot of interactions with a lot of OT third parties, manufacturers, et cetera, components. Definitely earlier on years ago, you know, when you breached the topic around, hey, you're providing a solution that's on a legacy Windows version, the response typically had been, you're the only person that's asking me about it. Mm-hmm. You know, with the more hype and the news focused and all these attacks on cybersecurity, it's becoming more of a regular requirement for end customers to get solutions that are actually on supported platforms. So I'm definitely seeing a better adoption rate in terms of purchasing equipment and actually having the availability of a modern Windows operating system under it. But again, we're nowhere near 100%. There's still specialty equipment that is operating closer to legacy times. Just to add on to that, you know, some of the challenge also is after they produce you a solution on something like, let's say they gave it to you on Windows 10 today, what is that OEM's ability and those OT manufacturers' ability to continue that support, to have that support for evaluating the patch and the compatibility, and then after Windows 10 is off support and we're in several versions of Windows in the future, will they offer a upgrade path at that point? A lot of that legacy XP was we had vendors that did not offer a path going forward without a full replacement of the equipment. And sometimes that equipment is, oh, that one machine there, you want to upgrade that Windows machine. Well, you have to buy a new $2 million piece of equipment with the latest and greatest everything. So definitely making progress, but still lots of challenges.
Thanks, David. Other panelists would like to chime in? All right, so let me move on to the next question from the audience. Servio asked, blockchain requires to share data and code like in form of smart contracts in the chain to reach consensus and ensure transparency. What methods do you envision will protect the privacy of computation and data in current and future blockchain networks utilized in Industry 4.0 in particular?
Yeah, so probably I'll take the lead on that question from my side. So this is indeed an interesting a challenging point that when we start talking about the privacy and transparency together. So there are already some solutions which are theoretically feasible in terms of the zero knowledge proofs or ZK proofs. Some people might have heard about, as well as the cryptographic techniques associated with the encryption, as well as multi-party computations. And the challenge with this is we still are not making we may not be able to make them to scale for today's requirement. Just to throw a number here, that let's say we do not worry about privacy and we want to have a blockchain-based service working for our industry, maybe we can manage 1,000, 10,000 transactions per second easily with the permission environments. However, when we add any such privacy measures, it becomes challenging because maybe there will be overhead, and you can call that to be easily 2 orders of magnitude these days. So we are going to maybe 100 transactions per second management, and that may not be satisfactory whatsoever for big industrial environments. So how to scale them either by innovation in cryptography or by innovation in terms of the sharding and other distributed system techniques remains to be challenged, as I see, and we need to make more efforts to make it better and faster before we use it.
Dongyan, I'd also, so I agree with Aniket. I want to take maybe a little bit different approach to to what I would add to this conversation, and that is when we talk about sharing of information and transparency of information, and sometimes that gets wrapped up in some sort of, for example, OEM and supplier relationship. Often those relationships are governed by contracts, legal documents that people sign. And while blockchain could in fact help in a scenario like this, I also think there's another element to this which has to do with sort of technical literacy, data literacy, and understanding on the part of the whoever is the giver and whoever is the receiver of the information, exactly what it is they're giving and what it is they're receiving. I see a lot of this at times in my interaction with the DoD and some of their acquisition and sustainment programs, where someone in a program from an acquisition side just says, well, to the OEM prime, okay, I just want all your technical data, give me your digital, this, that, and the other thing. I want it all. And in many cases, they don't really even know what they're asking for. Moreover, let's say they got it all, they wouldn't even know what to do with it if they had it. And so I guess my point being is that in as much as there's a technological solution, I also think that there's a little bit of a literacy solution and an educational and maybe even a business contractual kind of a solution as well.
Thanks, Nate. Anyone like to add to that? If not, let me ask my question. So I would like each of the panelists, to identify your technology to watch. So could you name one new or emerging concept or technology that you find the most practically promising for securing Industry 4.0? Things can, examples are 5G, AI, analytics, et cetera, et cetera. So in your opinion, what technology or what concept might be the most practically promising for securing Industry 4.0?
Dongyan, I'll take maybe a first whack at that.
Yep.
In my view, Industry 4.0 is fundamentally premised on the idea that we're not just digitizing information, but we're digitalizing practice and process along with the information. And
I agree.
For me, I think it's not as much of a technology that is as promising, but the ways of working with standards. Because I think in order to be able to move information from here to there without it falling apart, and also securely, there's going to have to continue to be some amount, hopefully not an overreach, but some amount of standardization of either the senders or the receivers or the information that move data along that thread. If not, my concern is, we'll continue to have so much variability in the market that things won't reach their full potential.
Thanks, Nate.
I'll answer next about mine.
Please.
The technology that I kind of see really approaching us fast with a huge impact would be AI. Okay. And I say that because, when we look at AI in the context of data analysis, first of all, we have existing large amounts of information that are already captured. But unfortunately, a lot of that information may not have the context. And contextualization is what really makes that data useful. And, it would be a lot of man hours to go back through all the data sources to try to do all these correlations, et cetera. And that's definitely a play where a lot of vendors are applying AI to try to gain those insights from existing data sources with less need for manually going back into the data and redoing and cat tagging, et cetera, all the metadata. Also, it'll help us get to, predictive analytics, but also this concept of prescriptive analytics, which is not only am I going to detect a failure or an opportunity, but I can actually prescribe, what you should do, what actions should you take, et cetera, in that particular situation. Those are definitely areas that I'm seeing a lot of movement from the industry perspective and from the suppliers of solutions.
Thanks, David.
So I'll take a little bit different tact, if you will.
Please.
and it may be a little bit biased working for a Department of Energy lab, but
go ahead.
now there was a recent award of a Cyber Manufacturing Innovation Institute, or SIMANI, as it's referred to. And really, when you're looking at transforming an industry, what you need to do is rally towards a common vision and provide sort of the resources where you can deploy and test and validate these innovations at a pace that is not always possible, with an individual company. And so, if successful, these institutes are really supposed to be priming mechanisms for transforming the market. And this particular one is focused on securing manufacturing in the context of how you optimize it for physical and energy efficiency and other reasons why you're trying to optimize your supply chains or your manufacturing floor or other things. And so I think things like that really can amplify not just individual technologies, but move groups of technologies and groups of industries in a different direction. I think that's really going to be impactful. And so it's a business take rather than a technology take, and sure, hopefully you'll forgive me.
That's the one to watch, right? Thanks, Wayne. Aniket.
Yeah, so I guess continuing from the discussion that's already happening, I guess analytics is indeed certainly something to watch for, and we have to pay more and more analytics. And there is already a lot of innovation that's happening in the AI space. What I find could be interesting is that possibly can we perform this AI with the data that's coming from multiple sources and environment, while making sure that we achieve both two properties, the provenance, that we can indeed make sure that the answer that we are generating are meaningful and can be possibly linked to the data that's coming to, with explainability being a huge challenge there. And at the same time, can we do these analytics and do these AI computations, learning as well as inference, in a manner which is secure in the terms of privacy preserving as well as correctness. So those could be possibly game changer when we not only have now individual data, but we can combine them across different channels and gain better insight while protecting security.
Great. Thanks, Aniket. All excellent points. Thank you very much. So my next question, since this is a panel, this is an event hosted by a university, by an academic institution, how can I miss one of my favorite topic of discussion, education and workforce development? So from your perspective, what are the challenges and opportunities and maybe best practices in education and workforce development in the context of Industry 4.0 and Industry 4.0 security, education and workforce development?
So I'll say something. I mean,
please.
I think that symposiums and forums like CERIAS are a phenomenal opportunity for students and for others really looking to get into this industry. To be able to have such deep knowledge speakers and panel members, et cetera, to gain some insights is definitely a good kickstart. Some of the challenges are when we think about the skill sets required. These skill sets were already in shortage in the labor markets. When we want to hire some process automation people to work shop floor, but then we also want to talk about data integration and Industry 4.0, and then you want to load cybersecurity on top of it. You're talking about a rainbow colored unicorn that you're trying to recruit, not just a regular unicorn, right?
Exactly.
And so, it's great to have these things for education to continue to move. There's a lot more cyber programs now. There's a talk later on cyber apprenticeship programs. Those are phenomenal opportunities, also upskill. So definitely a lot of opportunities in academia and private sector and conferences, et cetera, to really get started on learning more about these things. From an industry perspective, we don't go in thinking that we're going to find a student that hits all three of those key areas. It's all around the learning agility that you demonstrate. You've got a good foundation. You may know one or two of those areas, and you can quickly learn the third, or possibly the second or the third.
Yeah. Great.
Dongyan, I'll
yes.
piggyback on what David said, and part of it I think is about raising awareness that these items are in fact important. Secondly, in addition to, and again, I know there's another presentation later about an apprenticeship program, but this concept of work-based learning to be able to train students in representative environments to the extent possible, and then partnering in some way with industry to make sure that the representation of that educational environment is in fact authentic to, again, to the extent possible that students can experience. And I would say thirdly is working, and this is really more for us in an academic environment, but that is, working across the organizational silos, right? I mean, it's,
yep.
Universities at times are just as siloed as companies are. And so it's, so I think, working to where, we can bring the most value with whatever the background and expertise is, and finding a way to address that problem is certainly, I think, an opportunity that is ripe for the picking.
Great point. Thanks.
So there's kind of 4 challenge areas here. One is just the raw scale and the numbers that we're fighting in multiple domains here. The second is how you get to some form of more rapid hands-on competency, right?
Exactly.
Third is it's multi-domain. Manufacturing and industry, more than anything else, really pushes the limits across domains. And then there's this approach that if you're trying to be proactive, it needs to be by design instead of reactive, right? And that's a different set of education principles than sometimes some curriculums teach. Now that said, since the entire market is moving towards these data-centric and immersive environments in mod and sim on the design side, as well as the plant side, there's an opportunity to embrace that on the education side as well too. And so I think you can work the scale, the multidisciplinary, realistic hands-on scenarios. Now, those are hard environments to build. It's not trivial, but I think the whole market's moving that way. And so education might as well too.
Absolutely. Thanks, Wayne.
Yeah, so I guess starting from where Wayne left regarding indeed having experience associated with the market itself, one thing that I like to add there is that from the student learning perspective, to have a good outcome when they go to the industry, it can be relevant and important to have some kind of a knowledge and knowledge regarding security. So if students can indeed take some security course while they are doing their studies, could be relevant, because now or in the future, the product that they're working on can become prominent. And once they become prominent in current global distributed environment, they have to deal with the security issues heads on, and knowing about those well in advance could be a key distinguisher.
Great. Thank you so much. So with that, I believe we have come to the end of this panel, but obviously the discussion should definitely continue. This is just such an important issue to discuss and a challenge to address. Audience, I would like to encourage you to continue online discussion on the Slack channel. Our panelists will continue to check the Slack channel to respond to your questions, and also we can do some discussion among ourselves. I realized that I did not allocate time for the discussion or comments from the audience in the interest of time. So with that, I would like to conclude the panel, and I would like to thank all the panelists and all the attendees for their very insightful comments and remarks. Thank you.